Hello, good morning. In the previous class, we will study the concept of entropy and a shortcut idea of the change in entropy. So, we will continue here. So, this is the diagram for the change in entropy of the substance. So, here L, M and other two adiabatics and T1, T2 and T3 are the three isothermals and separated by the same but small but equal distances. Okay. So this A, B, C, D is the first Carnot cycle, and this C, D, E, F is the second Carnot cycle. So during the first Carnot cycle, Q1 amount of heat is absorbed by the source at temperature T1 in going from A to B. Okay, and in the next step, Q2 amount of heat is rejected to the sink in going from C to D at temperature T2. Therefore, the efficiency according to Carnot theorem, the efficiency of Carnot engine A, B, C, D is given by 1 minus Q2 by Q1, which we will see in the previous class. Okay, and in the previous class we will see the equation Q1 by T1 is equals to Q2 by T2 is equals to Q3 by T3 is equals to delta dash constant. So this equation we will study in the previous class. Okay, so after that we will continue here. So we have this equation Q1 by T1, Q2 by T2 is equals to Q3 by T3 is equals to constant. So after that, in general case, this is a Q1, Q2, Q3 number of isothermals and number of adiabatics we will study here. But in general, if Q is the amount of energy, if Q is the amount of energy absorbed or rejected, Q is the amount of energy absorbed or rejected. Okay, if Q is the amount of energy absorbed or rejected at temperature T Okay, so this concept we will study in the general. Here Q1, Q2, Q3 for the three adiabatics, for the three isothermals, and T1, T2, T3 are the three isothermals. So in general, if Q is the amount of energy absorbed or rejected at temperature T in going from one adiabatic to other. In going from one adiabatic to other. Okay, Q is the amount of energy absorbed or rejected at temperature T in going from one adiabatic to the other. Then we can write here Q by T is equals to constant. Okay, here Q1 by T1, Q2 by T2, Q3 by T3, Q4 by T4, then again Q5 by T5, then up to n number. So in general we can write this Q by T is equals to constant, and here Q is the amount of energy absorbed or rejected at temperature T in going from one adiabatic to the other. Okay, here one concept. So if two adiabatics are very close to each other, here we draw three adiabatics, three isothermals and two adiabatics. Then next, if two adiabatics are very close to each other, then in that case, del Q is the small quantity of heat absorbed at constant temperature T in going from one adiabatic to another. Here Q is the amount of heat energy but here two adiabatics are very close to each other. Therefore, if del Q is the small amount of energy absorbed at constant temperature T, then del Q by T is also constant. Okay. So this constant ratio is called the change in entropy. So this constant ratio is called the change in entropy between the states represented by the two adiabatics, and this ratio is denoted by the delta S. Delta S is equals to delta Q by T. So this ratio is called the change in entropy and denoted by the letter delta S. So if we consider the change in entropy for the finite reversible change in the state of working substance from A to B. If we consider state A to B, therefore this change in entropy, that means SA to SB for the finite state A to B. So delta S is equals to integration A to B delta Q by T. So this can be written as a SB minus SA is equals to integration A to B, here finite, that's why we get dq by T, and here finite, so for the ds is equals to dq by T, and SB minus SA is equals to integration A to B. So the expression integration A to B dq by T is equals to integration SA to SB ds is the function of thermodynamic coordinates of a system. So this function is represented by the symbol S, is called the entropy. So this expression SB minus SA is equals to integration A to B dq by T is represented by the letter S. So therefore S is equals to simply Q by T. This is the entropy. S is equals to Q by T. Or we can write this S is equals to integration A to B dq by T. Okay, so this is the change in entropy of the system. So this is the total concept of change in entropy of the system in other different form. First form is the Q by T is equals to constant, means if we consider general concept, that is the Q by T is equals to constant, and if two adiabatics are very close to each other, and if delta Q is the small amount of energy absorbed at constant temperature T, then in that case we can write delta Q by T is equals to constant, and this delta Q by T is equals to constant ratio is known as the delta S, that is the change in entropy delta S. This delta S is equals to delta T delta Q by delta T. So then again, if we consider the change in entropy for the finite reversible process in going from A to B process, okay, if we consider finite process A to B, so in that case we can write entropy for the A system, A initial state, and entropy for the final state A to B state. So this is the finite state, so that's why this is the general state, therefore we write here small change. So this is the finite process, so we write here perfect differential, that is the ds is equals to integration A to B dq by T, because this is a finite, so that's why we write the perfect differential, okay, dq by T. And if we write in the form of SB upper limit minus lower limit, SB minus SA is equals to integration A to B dq by T. So this expression integration A to B dq by T is equals to integration, we write here integration A to B dq by T is equals to integration SASB and ds. Okay, means from that this is also same and this is also same. So integration a to b dq by t is equals to integration sa to sb ds is the function of thermodynamic coordinates of the system. So this is the function of thermodynamic coordinates of the system. Okay, so this expression is the function of thermodynamic coordinates of the system, and this function is represented by the symbol s, and this function is represented by the symbol s, and it is called the entropy. So finally we conclude here, S is the symbol for entropy and it is the function of thermodynamic coordinates of the system. Okay, so this is the total change in entropy of the system. In the next class we will see the principle of increase of entropy, or the principle or law of increase in entropy. That means the change in entropy in the irreversible process. Okay, thank you.